So the student here, they had to summarize these 2 pages of first year material and produce a title, produce a couple of key points. They're supposed to attract the attention of a hypothetical audience. The idea is, suppose you had to give a presentation on the Scalar product. What would you put on the first slide? You put a title, and then you want to put a couple of catchy items that would encourage people to listen. So the first student the first student has not produced, in fact, these two key points. There is a title, which is perfectly adequate. A scalar product of 2 vectors and its properties. And then there is a competent, if a bit dry, delivery. So the student starts off with the definition of the scalar product, and then is confronted with a long list of detailed information in these 2 pages. There are several paragraphs. Each paragraph contains a piece of information, and he has decided to actually produce a kind of itemized list. Now, it's an effective delivery. I mean, normally just listing things is not very. It may be very boring, but if one had to do it, then this way is certainly the best way of doing it, because you don't try to hide the fact that you're listing things. You actually do it explicitly, and so it becomes more forceful and nice. And then the student finishes up with spotting the fact that there are 2 ways of computing the scalar product, and he makes some comments about that. My criticism of this assignment is a bit dry. It doesn't quite tell a story. So there is an item at the beginning, an item at the end, and then a fragmented bit in the middle. So you get all the information that you need to get, but it's not relaxed. It doesn't flow necessarily. And another thing is that the proofreading is lacking. There are spelling mistakes, but also just typos. And for a mathematician, proofreading is very important. In fact, it's one of the big selling points of having a degree in mathematics, that we can cross all the T's and dot all the I's and note the insignificant details that normal people don't. So, with a little bit of proofreading, then this assignment could improve considerably. The second assignment, there are the key points, and the 2 key points are very well chosen. The first says 2 ways of computing scalar products, and the second one says finding an angle between 2 vectors. Now, they are well chosen, but not necessarily well delivered. So they tell you what important points are. They're not catchy. And then the arrangement of the material is different from the first assignment. Now we have 3 paragraphs, and each paragraph deliver information in a very, very effective way, concise way, and there is nothing missing in this assignment. There is a very good synthesis of the material. One illustrated grammar. After some rearrangement, we find other way of obtaining the dot product, another way. But apart from that, this is there is also some missing articles in another sentence. Apart from that, this is a nice delivery. I would say that the level of proofreading here is, the quality of proofreading is higher here than the first assignment. Then we have the final assignment, which is really very nice. the key points. There are three key points. The first says it takes two vectors and produces a scalar. So it's a sentence rather than a phrase, and it's a bit more punchy. And then it says it can be defined in two ways. Compare this with two ways of computing scalar product. Right? So this one is more assertive. There is a third key item, which is satisfies certain laws, which I find slightly a bit vague. But the first two are very good. And then there is a very competent delivery. I'm very pleased with this assignment. The format is the hardest of all. It's just a single paragraph. And so it's very difficult to deliver all the information in a concise way without being cryptic. But the students manages to achieve this really very nicely. It starts off with a scalar product or dot product. So there is an alternative definition in parentheses, which is a nice way of putting it out of the way. It's an operation that takes two vectors, parentheses, the vectors can be equal, and produces a scalar. So there is a fine point of, there's a nice point that take any two vectors, but any mathematician knows that if you take any two vectors, you still allow yourself to take twice the same vector, right? And he makes that point in parentheses. So so they're very nice points of rigor, which are sort of slightly removed from center stage, so it makes the delivery very fluent. Then the operation can be defined algebraically, where it is the sum of the products of the corresponding vector components, or, if the vectors are non-zero, geometrically, where it is expressed as the product of three quantities, namely the norm of each vector and the cosine of the angle between the vectors. So this is really good. It's a complex sentence with a lot of dependent sentences, and it requires a very good command of the syntax. The use of punctuation is absolutely necessary for this type of delivery, and then also the mathematics of it. The fact that this operation can be defined algebraically on the one hand and geometrically on the other hand. So there are these two big items at the beginning of each of these two sentences. And there's a nice point that they said that the geometric descriptions requires the vector to be non-zero, because you need to have an angle between them. So this is again an attention to detail. Then by combining both definitions, one can compute this angle, the angle between the two vectors, if one wishes. So this is also it's a nice sentence, because it tells you that there is a way of using these two definitions without getting into the details. So it will certainly prompt people to read more, to find out more. And then it says the scalar product obeys certain algebraic laws, in particular to enjoy commutativity and distributivity over addition, etc., etc. So these are grown-up terms, so to speak. These are terms that are used normally in abstract algebra, and they're very nicely used in this context. So this is elementary mathematics from a slightly more advanced standpoint. A useful fact is that the scalar product of two vectors is zero if and only if the vectors are orthogonal, i.e. perpendicular, or at least one of them is the zero vector. Also, again, a parenthetical remark that reminds the reader of what orthogonal is, in case you have forgotten orthogonal is perpendicular. So this is really a very competent delivery. I would find it harder to write a better paragraph on the scalar product.